Welcome to my video on work and the dot product. In this video, what I'm going to look at is the basic definition of work. It's right here. And that is just the dot product of the force vector times the displacement vector. And we've talked in previous videos about what the dot product is, so go back and look to those. I'll put a link in the back of this video to that. Our units for it can be a joule as a unit of work, and that is just a Newton times a meter, or a Newton meter. Now, a joule is really not a very large amount of work. It's about the amount of work it takes to lift an apple over your head. So in this diagram here, we show basically there's your displacement vector D, and there's your force vector, and they're not necessarily collinear or in the same direction. They can be in different directions. And we handle that with a dot product. So here's the angle between the displacement and the force vector. And so this gives us the amount of force that is in parallel to the displacement vector. So that's the result of the dot product. Now we talk about positive work, and we're going to talk about negative work. So positive work done on a system to increase the mechanical energy, either potential or kinetic. So if you have a backpack full of books and you lift it from the floor and put it on the desk, you've now increased the potential energy of the backpack. So you've taken the system of the backpack, you've increased its mechanical energy. You put work into the system. Now, negative work is done by the system and decreases the system's mechanical energy. A softball or soccer ball is rolling on the grass, it comes to a stop. What has happened there is the kinetic energy of the ball has been converted into mechanical energy by bending the grass, which turns into heat and to motion. So you've taken the kinetic energy of the ball and turned it into heat energy or mechanical energy. So that's the work done by the system and decreases the system's mechanical energy. Now has zero kinetic energy. Now let's look at an example. A box is pulled 10 meters along the floor by a force of 20 newtons at an angle of 30 degrees above the horizontal. Find the work. So let's look at our system here. Here's our box, and the force is going to be at 30 degrees relative to the direction of motion, which is parallel to the floor. We're going to move it 10 meters, and we're going to have a force of 20 newtons. So there's what we know. And what we want to do is find out the amount of work. So let's go back to our definition of work is equal to the force vector dotted with the displacement vector. Now we know that that's just going to be the magnitude of the force times the magnitude of the displacement vector times the cosine of the angle between them. The magnitude of the force vector, we're given that that's going to be 20. The magnitude of the displacement vector is going to be 10. It moves 10 meters. And so we've got the cosine of 30. Now to calculate the cosine, let's go into our Desmos calculator to do that. So let's enter cosine and then 30. That gives 0.866. Now take this number back into our example. So we have 20 times 10 times 0.866. Brought that over from the Desmos. And that is going to be 173.2 joules or Newton meter. So that's the amount of work done by the system, really onto the system to make it move. So there's our answer. I hope you got something out of this video, learned a little bit about work. The dot product of work is equal to force dotted with a displacement. If you did, give me a like, thumbs up, and subscribe to my channel. Thank you for watching.